All right, so welcome to this quick lesson on how to do distance and displacement problems. It should be very easy. You have the first example problem in front of you. So we got this runner who's running in one direction, forgets what, drops her keys, and that's turn around. So basically, when you read that, all right, the picture should be forming in your brain, in your head, on what's happening. So you got to imagine this runner starting here, all right. Let's see if I can get this to work. And then runs out this way, then turns around, runs back this way, and then from this point goes on this way. All right, you should kind of see that where this is 16, let's get these things to work, 1650. All right, this one here is just 800, what's going on here? 875, and this one is 2200, all in meters. All right. So they want to know the displacement and the distance. So the displacement, remember the definition for the displacement is how far, in other words, displacement is kind of like, is a special type of distance. It's the distance from where a straight line distance from where you start to where you finish. So that would be from here directly to here, all right? So you can see we have 1650. All right, 1650 there, but then it gets a little tricky. We've got to figure how much that is. All right, so that's what you should kind of be visualizing. But if you approach it from a math type point of view, it's a little bit easier. All right, you can just add these things up. They went 1650 this way, so we can go delta D. So you go to 1650 that way, but then they had a minus 875 because this one is in the opposite direction. It's going that way. All right, it's going this way while these ones are going that way. So this is a positive direction, that's a positive direction, but that's a negative direction. So displacements are vectors. So 1650 minus 875, then plus 2220, all in meters, gives me a total displacement of, and I don't have my calculator here, here it is right next to me, so I want to go a little bit faster, 1650 minus 875 plus 2200 gives me a total displacement of 2975, and make sure we put the M for meters. There's this displacement. Now the distance, part B, is a little bit easier. Okay, so to do distance, remember distance is just a scalar, so they don't have directions, so we don't have to worry about the positives and negatives. And so you can see, well, they traveled this far, and then they also traveled this far, and they also traveled this far. It doesn't matter that this one went backwards. Displacement, that matters. We took that into account here. But for distance, we just add them all up. Sorry, distance, we'll say distance total is equal to 1650 plus 875 plus 2200. We add all those up and we just get 1650 plus 875 plus 2200, and we have 4,725 meters for total. All right, so it's distance is definitely the easier one, but displacement isn't bad. Sorry, just remember you got to watch and figuring your positives and negatives when you're doing displacement. Displacement is vector, has positives and negatives. Distance is just add them all up. All right.